everyone, welcome to Ecoholics. In this video and in our next few videos, we will be discussing numericals based on cost functions. So let's get started. Let's look at this numerical. If Q is equal to A KL raised to 0.5, what is the short-run cost function when K is equal to 100 and what is the marginal cost function? So let's first understand what is short run. Now, so short run is that period of time in which output can be increased or decreased by changing a variable factor such as labor, raw material, etc. So only a variable factor changes, whereas quantities of our fixed factors such as capital equipments and machineries, all these factors remain constant or fixed. So what we have studied in short run is that a variable factor changes and our fixed factors remain constant or fixed in short run. So in a short run cost function, what we can say is our total cost is equal to total fixed cost plus total variable cost. Now let's first understand what a fixed cost is. So now, fixed cost is that cost which is incurred by the firm independent of the output. Now what does that mean? Even when the output is large or small, such costs have to be incurred by the firm. An example of our fixed factor is capital equipment, machineries, etc. Now let's understand what a total variable cost is. Now, total variable cost is incurred by the firm for, let's say, employment of labor, for raw materials, etc. So total variable cost in the short run varies or changes, whereas our total fixed cost remains constant or fixed in the short run. So this becomes a short run cost function. Now in the question, what do we have is, what is marginal cost? Now, let's understand the concept of marginal cost. So, marginal cost is the addition that is made to the total cost when one extra unit of output is produced. So, how can we represent marginal cost? So, basically, what we have studied is, it is addition made to the total cost when one extra unit of output is produced. So how can we represent it? So marginal cost is equal to total cost of n units minus total cost of n minus 1 units. So this is basically the addition that is made to the total cost when one extra unit of output is produced. So this completes our marginal cost. But now, there's one more thing I would like to say. Now, we have seen that our marginal cost is equal to this. Now, total cost, we have already studied that. Total cost is equal to total fixed cost plus total variable cost. Now, on similar lines, what we can say is our marginal cost is equal to total cost is total fixed cost plus total variable cost. But in this case we will write total fixed cost of nth factor. This is because in the short run our fixed factors remain, the quantities of our fixed factors remain constant or fixed. Only our variable factor changes. Therefore, we have this TVC N. Now, similarly, this can be written as total fixed cost plus total variable cost of n minus 1 units. Now, simplifying this, what do we get is marginal cost of n units is equal to total fixed cost plus total variable cost of n units minus, so now what do we get here is total fixed cost minus total variable cost of n minus 1 units. Now, total fixed cost, so TFC minus TFC, 0. And then what do we get is marginal cost of n units is equal to total variable cost of n units minus total variable cost of n minus 1 units. So, marginal cost is basically the addition that is to the total variable cost when output changes from n minus 1 units to n units. Now, using all these concepts, let's look at an example. So, it's given that Q is equal to A KL raised to 0.5. And in our first case, we need to find Shortrun cost function. So we need to find this. So now, this shows us that we have two factors, labor and capital. So we have two factors, labor and capital, L and K. And we have seen that in the short run, output can be increased or decreased by changing only a variable factor. And a fixed factor or the quantities of fixed factor remains constant. So, L becomes, in this case, L becomes a variable factor and K becomes a fixed factor. Right. Now, it's given that K is equal to 100. So, now substituting K is equal to 100, we get Q as A 100 because K is 100. So we are going to substitute K is equal to 100 in this. What do we get? K is 100 L raised to 0.5. Now, we have studied that a short run cost function is given by, so a short run cost function is given by total cost is equal to total fixed cost plus total variable cost. Now, we have seen that our L, that is labor, is a variable factor. So, our total variable cost will be what? So, our total variable cost will be equal to W into L. Now, what is this? So, W is basically wage rate. So, W is a wage rate. So, this is total variable cost is equal to wage rate multiplied by total number of laborers that are employed. So, this becomes our total variable cost. So, substituting this, what we get is total cost is equal to, so total variable cost is W into L. Now total fixed cost. So our fixed factor is our capital. So total fixed cost becomes equal to R into K, where R is the rental cost of capital. So R is the rental cost of capital. So total fixed cost becomes R into K. Now substituting this, what we get is R into K. Now further it's given that K is equal to 100. So when K is equal to 100, total cost is equal to R into 100 plus W into L, because it's not given, R, W and L are not given. So we will keep this as it is. Now, next is we need to find marginal cost function. So this becomes our short run cost function. So our short run cost function is 100R. This can be written like this. $100R plus W into L. So our short run cost function is 100R plus WL. Now let's look at the second part of the question. What is marginal cost function? So now our total cost we have found is, so from our previous slide we have seen that our short run cost function is 100R plus W into L. Now, and a Q is equal to A 100L raised to 0.5. Now, from this equation what we can get is, let's say we can square this. Okay. So when we square these terms, what do we get is Q square is equal to A square into 100 L raised to, this is 0.5 and we are squaring this term. So what we can get is Q square is equal to A square into, this can be written like this, right? So we can write this as under root of 100L. Now finally what we get is under root of 100L whole square will give us 100L. So now this is what we get, and from this we can also derive our L. So our L can become like this, Q square divided by 100 A square this is equal to L. So now to get L, we have squared this term. So now what do we get is our cost is equal to 100 R plus W, that is our wage rate of labor, multiplied by L. Now our L is equal to Q square divided by 100 A square. So Q square divided by 100 A square. So now this becomes a cost function, like this has become a shortened cost function by substituting the value of L. The value of L, that is Q square upon 100 A square, we get this. So this is like we are substituting the value of L, and this is again a shortened cost function only, but there are two ways in which we can write this. Okay, so next, marginal cost function. We have seen that a marginal cost function can be written as marginal cost is equal to total variable cost this of nth unit minus total variable cost of n minus 1 unit. So this is our marginal cost function. We can write it in both ways. We can also write it as this marginal cost function this. So we can write marginal cost in both ways. So now we will just look at this now. Now, in this case, what we have seen is this term. So here we have seen that our total variable cost. Our total variable cost is W into L. But we have further substituted the value of L, that is L, as Q square upon 100 A square. We get our total variable cost in this as, so total variable cost in this case is W Q square upon 100 A square. So this was our total variable cost, which we get by substituting value of L as this. So now what we are going to do is, using this value, that is TVC is equal to W into Q square upon 100 A square. So W into Q square upon 100 A square. Now what do we get is, so this marginal cost function can be also written as differentiation of TVC with respect to Q. This is because our derivative represents change. Change in variable represents our derivative. So MC can be written as daba TVC upon daba Q. So we are differentiating with respect to Q. Now we are going to differentiate this term with respect to Q. So daba TVC upon daba Q is what? Now this term, that is W upon 100 A square, this remains constant, right? So this is our constant term, and we are going to differentiate Q square. We are going to differentiate Q square with respect to Q. So what do we get is daba TVC upon daba Q is equal to W upon 100 A square. This remains as it is, into differentiating Q square with respect to Q. So we have studied in our previous videos, we have studied various rules of differentiation. So this is our power function rule. So our power function rule states that of differentiation states that when y is equal to x raised to n, then our dy by dx is equal to nx raised to n minus 1. So in this case we have n is equal to 2. So now we are going to differentiate q square with respect to q. In this case n is equal to 2. Then we get 2 into q raised to 2 minus 1 is 1. So we get derivative of q square as 2q. So this becomes equal to 2q. And this is our derivative. So our marginal cost will look something like this. So it will be equal to W. So it will be, we can also further simplify this. So what we get is, we get W into Q divided by 50 A square. So this becomes a marginal cost function and this completes our answer. So we get marginal cost function as WQ upon 50 A square and we got short-run cost function as this. That is 100 R plus WQ square upon 100 A square. So we have seen how we can use the concepts of marginal cost, short-run cost function and solve this example. In our next video, we'll be discussing other numerical on cost function. So do like and subscribe our channel. Thank you.